All right, so today's classwork is actually a little different. We haven't done anything like this in class, so take a minute, copy that down. And again, if you don't have grid paper, all you're gonna do is just try to make a, a nice grid and copy those as best you can. So if you guys remember last time from one of our classworks, we talked about slides, flips, and turns. So slides, flips, and turns, as a reminder, a slide takes something and it just slides it in, whatever direction. And the term is translation. And then you have a flip, which is just kind of flips your object in any direction, okay? And then the rotation, and your rotation turns it. So that's kind of easy if you have a shape to move it in that direction. Algebraically, it looks a little bit different. It says, okay, if you have a shape, go ahead and given these coordinates, you're gonna move them. So first we have to understand the notation. If you have this shape, translate it to x plus 2, y minus 4. So what is that translation going to look like? So what does this do to this? So this says, if you have an xy coordinate, we're going to change your x coordinate. And what do you think you're going to do to your x coordinate? Oh yeah, you're going to add 2. Because x goes in the x direction, it's going to shift your x coordinate to the right 2. So it's going to shift your point right 2 units. Okay, well, what is this going to do to your y coordinate? Originally it was y, and now it's going to be y minus 4, right? So that's going to affect it in the vertical direction. So that's going to shift it down 4. And why down 4? Because it's negative. So this will shift right 2 and down 4 units. Now it says, translate shape ABC. Oh, we need to know where ABC is. Let's just make this A, B, C. Translate shape ABC using this mapping and give the new coordinates. Okay, so all I'm going to do is I'm going to take point A and shift it right 2 units and down 4. Right 2 units, down 4. I'm going to count that again, make sure I didn't make a mistake. Right 2 units, down 1, 2, 3, 4. So we say the new coordinates of A, we call that A prime. A prime shows that it actually moved over. And we're going to go ahead and give that those units. So that's -1, 1, 2, 3, 4, 5. So -1, -5. Okay? And we'll label that as A prime. Then we're going to take B and find our new B. So that's B prime. So in the same direction, right 2 down 4, right 2 down 4, B prime, and our coordinates are 0, -2. Over 0, down 2. All right, and then we're going to take our last point, C, and go right 2 units down 4. -1, -4. All right, not bad. And we can go ahead and draw our triangle. So we've created our new triangle, ABC prime. And that makes sense, and this is easy to see visually. Algebraically, there's also some interesting things to do. You could have done the exact same problem if I had given you these coordinates, -3, -1, just using algebra without using a graph. How could you get from A to A prime without graphing? Well, all you could do is you could visualize it, or you would just use your algebra. If you have the point -3, -1, which is this point right here, they're telling you you're going to add 2 to the x coordinate and you're going to subtract 4 from the y coordinate. So this would actually give you -3 plus 2 is -1. -1 minus 4 is -5. And you could have done the same thing for all of these points, listed them out, and then you didn't even have to graph it. Again, I like the visual just because it makes a little bit more sense, but you could do it algebraically or visually or both. That's it.